Okay, I think I'm connected. Is that right?
Okay. Yeah.
I'm connected. Okay.
Yeah. Professor Shukla, colleagues in the room, and distinguished participants in the online. It is my privilege to welcome Professor Shukla, Professor, a founding member of Department of Atmospheric and Ocean Science, George Mason University, KCA. I would like to thank him for accepting my invitation to deliver this online talk in commemoration of the 30 years operational service by NCMRW. Dr. Shukla is our founding member and has contributed immensely to establishing the operation system at NCMRW. To honor his contribution, we decided to start our 30th anniversary celebrations with his platform. So it is a great honor to have you with this, have you with us today and share valuable thoughts and vision. Once again, I would like to welcome you and now request my colleague Dr. Jagdish Mishra to formally introduce Professor Shukla.
Thank you.
Jagdish?
Yes,
Thank
sir.
you.
Am I audible? Srinivas?
Yes, I can hear. Yes.
So I hope I got 5 minutes. Otherwise, I can go on, introducing Shukla, sir. So it is my honor and privilege to introduce Professor Shukla. What you're seeing, couple of pictures in the background probably are from his, memory lanes. Padma Dr. J.S. Shukla is University Professor and Managing Director of POLA. POLA, you all are aware, is a center which has given us grads and many other things. Professor Shukla was born in 1944 in Balia district of Uttar Pradesh. He passed his high school in Asaras High School, Pyopur in 1958 with distinction in mathematics and Sanskrit. And he could not study science in high school because in those days, science were not available in these areas. So after passing his 12th grade from SC College Balia, he went to Banaras Hindu University, where he completed his graduation in 1962. He further completed his master's in geophysics in 1964. He then joined Indian Institute of Tropical Meteorology, Pune, in 1965, and he continued there until 1971. He did his PhD under Professor H.S. Rathod. This picture probably you are seeing in the background is during his PhD defense, if I am not wrong, sir. And his supervisor, Professor H.S. Rathod, Shukla sir, and P.K. Das, then DGM, was there in the picture. He completed his PhD in 1971 from Geophysics, Department of Geophysics from Banaras Hindu University. After that, he moved to Massachusetts Institute of Technology, where he did doctorate in science in 1976, the year I was born. Anyway, so and Professor Shukla has many awards in his name. Just to begin with, he is the Beck Family Presidential Medal for Faculty Excellence in Research and Scholarship. He is honorary member of American Med Society. He is member of India's Prime Minister Council on Climate Change. His Virginia Governors Commission, to name his Padma awardees from 2012. He has many awards. Just one or two to highlight here. He is currently the chairman of the International Advisory Panel of Weather and Climate for the Ministry of Earth Sciences. He is also a member of Prime Minister's Council on Climate Change. He was the scientific leader in the establishment of the Supercomputing Facility Center at National Center for Medium Range Weather Forecasting and in the establishment of this center as well. Remember last time when Professor Shukla visited our center, while introducing to him, John sir told he is an institute builder. So he has been instrumental in building several institutes. So one of the beneficiaries are us. I would like to. It's my honor and privilege to introduce him to this audience. He is currently helping. He's teaching in the George Mason University in that College of Atmospheric Sciences, and he is instrumental in the establishment of the private sectors in weather and climate enterprise in India. He established the Gandhi College of the Education in the rural women in the village of his birth in Balia, and he is also promoting this Gandhian philosophy by of honesty and provide the educational opportunity to girls from the neighborhood school. He was the leader of the bilateral US-India Science and Technology Initiative (STI) for monsoons. He was the science leader of Bay of Bengal Monarchs experiment in 1979. I can go on and on, but in the interest of the time and in the so that we all can hear more from Professor Shukla, I would now invite Shukla sir to start his presentation. And thank you very much, sir, once again giving me opportunity to introduce it. Thank you very much.
Okay. Well, thank you very much. You showed some of the pictures that I haven't seen for a long time. Is it possible to remove this my picture from the screen? My idea was really to just talk to people. Is this picture going to remain on the screen all the time when I'm talking? Or I would really rather like to see people. I don't know how you do that. Yeah. Okay, that's much better. That was much better. So no, actually, that lecture hall, I really feel like I'm lecturing in a lecture hall. Yes, and the reason is because, by the way, this is one of the first lectures ever that I have given without a PowerPoint. So this is like but anyway, before I start my lecture, let me really first thank Dr. V.S. Prasad and Dr. Srinivas Dirsamasity because really arranging this. And in fact, when before this, I have to thank Dr. Ravichandran and Mohan because they arranged my visit to NCMRWF in February, that I met many of you. And actually, I saw that tray in the lobby first time, and it brought such a nostalgic feeling to see that little. It looks like a sofa, like in a high-end sofa that you can actually use in your living room. So I really thank you all very much. I may not, I mean, I see a lot of people I have seen, a lot of my friends on the line, and I may not be able to thank all of you, but a lot of you have helped me in sort of in many ways. And this lecture is really the product of all the help I've got from so many people. So I think that every time I read your 25-year volume, everything starts with NCMRW was started in November 1989. Prime Minister came and inaugurated. So I thought, why don't I talk about what happened before that? How did the NCMRW got established? And I'm going to not show any PowerPoint. And obviously, it is going to be just a personal retrospective because for any major event like that, there are a lot of people who are working and helping. But before I start, how much time I have? Can somebody tell me? Because when there's no PowerPoint, you don't know when to end.
It's up to it's a 1 hour, so you can continue up to 5:30 IST.
Okay. Because I tell you, I want it to be conversational in the sense that I'll speak, but I really want to leave a lot of time for you to ask questions because there are things that you may be interested in knowing which I didn't know. So I think that because you see that March '89 when Prime Minister Rajiv Gandhi came to IMD campus to inaugurate, there was like a culmination of a lot of events that were happening before that. So my lecture will have two components. Okay, so in the first part, I'll give you the history. Okay, I'll give you the history of, and in the second part, I will talk something about the future. So I'm not reviewing NCMRWF. By the way, I did for like 6, 7 years, 8 years when I was chairman of IAT. So this today's talk, I'm just going to give you my thinking about where the field is going and what are the opportunities for NCMRWF to. So I think in the first part, I'll talk to you about so it's almost like a history talk, okay? And please don't hesitate to interrupt me. Okay, and the reason I really agreed to give this talk is that it so happens that some writer is writing my story about my village. All these things that Sinwar said. The village to MIT to NCMRWF to and so on and so forth. So I had all fresh. It's very easy for me to be able to relate that. But there are two things that will come out in this first part of the lecture. I want you to keep in mind. One is, as Srinivas said, I'm from a village. I just have tremendous affection for my village and from my country. And when I say my country, I mean, of course, I became a US citizen for whatever reasons, but I still think India is my country. And I've been here 50 years, and I have visited my village 100 times, I think, roughly. Of course, thanks to NCMRWF in some. So I think that this will come out because what I felt is that there are a lot of young people, and they should know that if you have an idea, if you have a passion for some idea, just go after that. Just push. Don't. And many times, if your advisor has a different idea, you should try to argue. No, this is my idea. Let's do it. And many times you find that your advisors and your bosses are very helpful. They will actually help you in really encouraging you to do that. So I think that, and I'll give you basically three examples of my own work because how simple ideas come to your mind, and just by your ability to be able to work on them, to insist on them, you can actually maybe make sense. So let me just say reanalysis. All of you know reanalysis, right? All of you know reanalysis, how reanalysis it is being used. Again, I can give a separate talk on the history of reanalysis. Nobody wanted to do it. Just nobody wanted to do it, let me tell you. And we at COLA said, because we felt this is really needed. And I went to NSEP, and NSEP said, no, we are not interested in. Then I went to European Center, and Benson said, yes, I'll do it. So that's how we get started. Then COLA did it. Of course, then later NSEP came up with a big reanalysis. Same thing with land. COLA has L, land. And the fact that land is important for weather and climate variability, it was not well accepted, an idea. But again, in a conversation with Yale Mins and Jules Charney, we felt that this is not a bad idea. But we were lucky that US government was giving us enough support that we could test ideas. So we wanted to show land is important. Well, we had the resources. But the center like NCMRWF, you guys are very lucky because you have so much resources. And you can test ideas. Is that what is called bombing? Is somebody bombing the call? Can you hear me?
Yes, sir. One of the participants had mic on. I just switched it off. Please carry on, sir.
Oh, you can hear me. Okay, fine. And of course, the last idea I wanted to tell you was about the dynamical seasonal protection. Yeah, I mean, you can mute yourself, then I think it's easier. And then once you do that, and it is again, I have to give credit to, so I don't see any people, I just see a microphone on the table with name of Sheikh Misra. Yeah, so that's right. I think this is yeah. That's much better. It's better to talk to people rather than talking to a table or a desk. That's why I'm trying to make because I just say 99% of the time we have. So, Mr. Ji, can you put the people on this screen? It was there all this time.
Yeah. Yes. Can you see this?
No. I only see the terminal of Mr. Ji. Yeah, that's right. That's much better. Okay. So because although it's a remote call, you at least feel you are talking to an audience rather than talking to a dark screen. Okay, so now, so I was just telling you those things only as a, I'm old enough that I can give what you call inspirational talks to young people, right? That I think that be bold in your thinking. If you have new ideas, just say, go and tell your boss, and you have the resources, and you can test your ideas and see, and you can prove whether it's right or not. So, with that kind of simple background, and by the way, my advisors were big people: Charney, Lorraine, Phillips, Manabe, all these people were my advisors. And I really think that you're very cooperative, very helpful, and most of the leaders are like this. They will help you in do what you want to do. Okay, so I think that now let's come to LCMRWF and to weather prediction, numerical weather prediction. Okay, when you come to numerical weather prediction, you should know a little bit of history. Now, I think you already know that Indian Vedas and Indian literature has tremendous amount of information about weather and climate. But when it comes to actual data, you'll be surprised that in the 18th, 19th century, people used to predict weather by using location of stars and planets. And there was a big subject called astrometeorology. Astrometeorology was a big subject. And when Columbus was taking his a trip to searching for India, found USA, he was using those methods to predict any storm in Atlantic. I was just imagining how it was. In any case, we have come and for the last 100 years, when in India, you use omens, that this happens. So where did the modern weather prediction start? And you can have a long, but I'll give you 3 dates. One is 1904. See, 1904, V. Bjerknes, not J. Bjerknes, just remember. J. Bjerknes is the one who gave the theory of El Nino. V. Bjerknes was his father. He just came up with this idea that, you know what, we'll use Navier-Stokes equations to predict future, just like we predict fluid. And we'll use the initial conditions to start because these are nonlinear equations. He knew that it would have to use. So that is the beginning, in my opinion, of the brilliant idea that let's use mathematical equations to predict weather. And then get the initial conditions. So fundamental requirements of NWP, he already defined. Now the question is, what model? What initial condition? There are not much there. And after 1904, the first person who tried to do it is Richardson, that you must have all read his book. He tried, and of course he failed, not because of anything else except that he didn't know how to filter the gravity waves. So the real breakthrough came in 1950. 1950, Jules Charney, that I have told you already about, who was the greatest meteorologist in the world, and von Neumann, who was the greatest scientist and computation and mathematician, they somehow met in Princeton at the Institute of Advanced Studies. And at that time, Institute of Advanced Studies has very, very big people, like Einstein was working there. Oppenheimer was the director of the institute at that time. He had come back from the project, nuclear project. And still, they really supported von Neumann and Charney. And they gave them support. Okay, you can demonstrate. And they did. And they demonstrated that, yes, by using mathematical equations. And so Charney ended up inventing the equations, which can be integrated and get solutions other than Richardson. And von Neumann ended up building the computer on which it could be solved. That's basically the birth of NWP in 1950. And immediately after that, many countries in the world really caught on that and started developing models and so on. So that is where we in India missed that revolution. Okay, we missed the revolution. I mean, we were running regional models, we were running quasi-geostrophic models, but the whole development of the primitive equation models and supercomputer, of course, we also didn't have a supercomputer. But I feel there was a computer in Tata Institute. So if we really put our effort in developing the global models, we could have gone and tested some. But in any way, that's sort of the history. So now I'm coming back now to my own interest. So I always go to India, either to go to my village to attend the Monex meeting, because Monex was going on. I was very interested in Monex. And this was one of my bad habits, is that any senior government official I'll meet, I'll pester them. How come we don't have a supercomputer? How come we don't have a global model? And of course, they'll say, yeah, that's a good idea. Of course, my biggest problem was Indian rainfall data. And India was not sharing the daily rainfall data those days. And as soon as they started sharing, by the way, you know that the entire monsoon research just exploded in India. The number they were not sharing not only with outsiders but also with Indian scientists. So those in one of those meetings, I met Yashpal. Yashpal he had just become secretary of DST, and I really liked him. He was very good, and he was also a very friendly person. And I said about, we need a global model and you need a supercomputer. And I was not aware, this was 1985. I was not aware while I was talking to him that Indira Gandhi had already told him, because there were some farmers in North India had a big problem. They had complained to him. So Indira Gandhi had told me, we need better forecasts. And he was thinking about it in the middle of that. So I was sitting in his office and he just stopped me. He said, okay, just stop. He gave me a big pad of paper, okay? And he said, here is a room. You write down how to do it. You just write it down. I said, what do you want me to do? Write down by hand? Yeah. Okay, guess what? I wrote an 8-page handwritten note about the equations, the computer requirements, model development group requirement, data requirement, assimilation, initialization, and post-processing. All these 8 things, and I gave it. And well, fine, I never heard from him. Then in the USA, suddenly we hear the news that Rajiv Gandhi met with Reagan in New York. He has gone for a New York for a meeting of the well. Now that meeting is referred to as the Tea Party meeting. And I'll tell you guys some anecdotes because I don't think it's written anywhere, but there were only 4 people in that meeting. And one of those people went to become professor in Carnegie Mellon, who was the science advisor of Rajiv Gandhi. Reagan was with his science advisor, White House advisor, 4 of them. And what I'm told is that Prime Minister said, we really need a supercomputer for monsoon forecasting. Reagan didn't know what is a supercomputer. He didn't know what is monsoon in general. So he turns to his advisor, according to a story I have heard. He said, supercomputer means what? Big computer? They say, yeah, yes, sir, big computer. Okay, good. Monsoon, what is monsoon? Big rain? He said, yes, big rain. Guess what? He was, because those days India was closer to Soviet Union, so US didn't want to approve sale of a high-power computer. I think Rajiv Gandhi basically convinced him. He agreed. The stories I have heard, he went back to to Washington, and everybody was against it. National Security Council against it, State Department was against it, CIA was against it, everybody. He told them, I have promised, and you guys have to do it. So that's it. So I don't know how many of you guys remember this story when the supercomputer came. It was in the satellite building. I was probably one of the few people who was really allowed to go inside the room, but I had to go through 3 to 4 layers of security. The whole IMD campus was sort of put, the Lodi Road campus. Then the satellite building, there was another security. Then the room where computer was, there were people in long rifles. They will just stand there, and you have, and inside the room was that little red thing that you guys have in your lobby. Anyway, I think that it agreed. We were very, very happy that the US has already agreed. And now I think that and US put such strict conditions, but Rajiv Gandhi was so interested in having this technical collaboration. He agreed on everything, all these security measures. India paid full price, 20 million. You could go and buy in a market somewhere for 6 million or 8 million. India, they charged. He said, okay, we'll pay. They agreed on. There was some haggling in the end, I was told, because India said, no, no, we really want XMP 24, but US will not agree. This agreed on XMP 14. So I think that final sale was made in 1987, and it came, and of course, now India had a supercomputer, but it's not just the supercomputer you need, right, to do MWP. India didn't have a global model. India didn't have a data assimilation system. India didn't have a prediction system, and then the post-process system, and obviously then verification system. So this is where I felt very good because I'm always want to work with India. I've been doing. Basant Gowarkar, who was the secretary of DST at that time, he called me, and I met with him a couple of times in Delhi. And I was a US citizen, so I couldn't get an actual job. However, he said that he got Senate, not Senate, I mean cabinet approval that US citizen, he can work. So I could go inside the room. I was also the link between the Cray guys who were there and the Indian scientists. So that's where the real work started. Okay, and this is what I think that the real work started at that time, and there were two joint secretaries that the government had given to help us. NCMRWF, we had to hire a lot of people. You know, there was a NW. So we sat down and made a list of all the scientists in the country, from IMD, from IITM, from IIT New Delhi. There was something going on. From PRL, there were people in her BHU, Andhra University. So I think that here was a very efficient system, and we needed to get people to come because there was no staff. Just imagine, there's a supercomputer, there's no model, there's no staff, there's no director. Okay, so I found actually, but Basant Gowarkar, the secretary, he said, you just do what you have to do and meet with people and talk to people and make. So we had to make like so many decisions, right? You know, one. And by the way, that trip, I mean, I came to Delhi like 14 times, roughly 14 times in 18 months. That's what I mean by it was so exciting that something so interesting is actually is happening. That I said, okay, let's. So we made all these decisions. So we said, okay, there are three options. Let's go to European Center, get their model completely, or get the Canadian model that was doing very well, or NSAP, because these were the three big ones that hurt. European Center will not give their model. Now, European Center director was Benson, who was a very good friend of mine at that time, but he just said, no, that's the policy, council policy. NSAP, NOAA, there was no collaboration at that time between US, India and USA. They were not willing to put any effort, but luckily, COLA had the NSAP model, the full NSAP model at COLA, because we were doing the analysis. So we had the assimilation system, and Canada would have been a possibility, but Canada's assimilation system was only hemispheric. And we really thought, no, we really need to start with the global model. And again, this is sort of so the decision was made that, okay, let us get COLA's complete system, which has assimilation and prediction. It is, after all, NSAP model. So although NSAP doesn't have people to help, there are enough COLA people who are willing to help. And so that's how we ended up with the COLA version of the NSAP model as the starting model. Okay, so now here are the problems. That modern assimilation system was run on cybercomputer, not on Cray. So now those are a few guys who are involved with this sort of software business. Now we had a question of really changing the code of assimilation, global assimilation system to work on Cray. That's number one. And in the assimilation, you need a preprocessor because once the data comes from all over the world and it used to come at IMD, you need a preprocessor. Well, what do you get? Who had the preprocessor? So European Center had the best preprocessor. And again, then I told Benson, can you give us just the preprocessor? He said, yes, I'll give you the preprocessor. But that was also written for cybercomputer, okay? So thanks to the technical staff that NCMRWF had acquired some. Oh, by the way, in the meantime, I didn't tell you, we were having a lot of recruitments. Now, you guys are so young that I don't think I'm recognizing anybody from the first batch. Is there anybody here from the first batch? Probably not. Huh?
And we are the oldest people in the center. Dr. John is there, and Dr. Saji. By the time we joined,
Yeah. No, so that's right.
So,
Yeah. No, anyway, that's so I mean, there are some of those people. So look, so Cray also was very interested to see that the system works because Cray was very interested. I mean, I see Mitra actually on the I saw his picture just a minute ago because I think he was in one of the early, right? He was in one of the early groups. There were several in those. Anyway, the whole thing was very exciting because you feel you are part of something, new that is happening. And Director General was Kulsrestha, and he was very helpful because just imagine, here I'm coming from USA every month. I have no position, I have no power, I have no authority. And so, but yet everybody's so nice to me. And we have to get a lot of things done, hire people, form the committee, invite people to come. We invited Sika to come and take, we needed more satellite data. So again, we needed IMD's help in getting more satellite data. And IMD produced a lot of more satellite data.
Question?
Yeah.
Sir.
Yeah.
Okay. So, of course, I joined in 92. But in the ECMWF model, the first model installed in that supercomputer was ECMWF model or Padma model?
I can't hear the question. I cannot see you. Just see, maybe, just tell me again. Yes. Yeah, keep it this way. You don't have to focus, actually, by the way. Leave that way. Yeah.
Yeah, I joined in 92. So before because when I joined here, Padma model was there, and that time we got the ENSAP model also. Because when I joined here, we got the Padma model. Before that, I heard that there was an ECMWF model, E79.
No. Okay. So there was right from day one, it was that COLA version of NCEP model. Okay, because ECMWF will not give any forecast system. But let me finish the history, okay? And we'll come because if anybody has a problem with the sequence, we can go over. And I'm gonna remember everything, but I just want to tell you, I wanted to thank that how everybody helped. IMD, we requested IMD. We need a lot more because their data receiving system was very good. We need to transfer that data to NCMRWF and then run to the preprocessor. We wanted much more satellite data, and they of course immediately started producing more satellite data. Hi, Tilal. I see my classmate from BHU. Tilal here. I decided to send it to. So I think that there were, India, NCEP, ECMWF, World Climate Research Program, University of Maryland, and my family. They all helped me. I just want to tell you, because just imagine, I came 14 times, but nobody was willing to give travel funds for my trips. Nobody was willing to give my salary. Nobody was willing to support my family's move to New Delhi. Okay, and because they say because there's problems, I'm a surgeon. So University of Maryland agreed that okay, so long as I advise my students, so that's why every month I have to go back to the university and somebody teaches, I can keep my job. WCRP through NOAA supported all my travels, each flight, everything. And my wife moved to her parents' house, so we rented our house, and that became a source of income. So we had to put it all together, and of course, constantly commuting. But with the help of everybody, we finally managed to do that. I just say it took about 12 to 14 rounds to do that. Uh, and the great thing was that Dr. Gowarkar had said to the Prime Minister, it will take 3 years. Uh, 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 by the way, you guys probably may know, but we did it in actually 18 months or so, 14 months. We had the whole system, as all the people described to you, and I couldn't have done it. I'm not actually a tech guy. So I'm like, sort of coordinating, but I was the director of COLA, and I had such excellent staff, and they were willing to come. They all came and they worked with the NCO, and NCO had hired excellent, brilliant scientists. And when you were involved with something new, everybody was really dedicated. It was doing that. So I think that finally, when it was at that stage, everything was ready. Then the secretary invited the prime minister to come and inaugurate that. That was the that you read all the time in '89. But imagine before that, there was so much work to be done in creating the infrastructure, having the battery power as a backup, because Delhi power, you cannot be sure, having the power connection and air conditioning, everything works. So this is very funny experience I had. So when Prime Minister started his speech, he says, there's one person I would like to thank. And I don't know whether he did it jocularly. And then he starts looking at the audience, and a lot of people are shaking, their bodies, and they think that maybe now he's just about to tell their name or something. And he said, that person is Ronald Reagan. And he basically acknowledged the help of Reagan to make that fundamental sort of commitment that yes, we'll give you a supercomputer. Okay, so now it was I think October '89. He had come in March. By October '89, for the first time, we the and when I say we, I mean my group and CMRW worked together. We managed to make 10 forecasts for 10 days with 10 initial conditions. And then we thought, this is working. And we verified them. And I mean, the forecasts were not very good. Indian data was a problem. And, imagine in 1989, Indian data was a real problem. And the upper air data, I really mean. And so finally, I think that we managed to announce to all the people who had helped us, government, the NSAP, European Center, scientists, work on everybody. I think that was in March 1990. That okay, we have a system now, and I can tell you the whole world was really exciting because everyone wanted to see a global assimilation prediction system in India in a way because it was part of the global weather forecasting system. So I really think that this is and then Mr. Sikka came because we need a leader, right? To get. We tried to get somebody from USA. His name was Desmukh. It was very unfortunate. India government gave him huge offer, very principal scientific officer, blah blah blah. The guy came and then left. So that was very unfortunate setback. And then Sikka came and as a because you need someone as a director. So I think that you can just imagine now that you now have NCMRW web, now you have people, you have computers, and now you just take off from there. So I'm not going to discuss what you have done from 1989 because, as you say, this is not. Uh, but I'm looking forward to reading your report. But I do want to talk a little bit about future. And before I say mm, my thoughts about weather prediction in the future, uh, there another incident happened which really became relevant for NCO. So 2006, Prime Minister Manmohan Singh came to Washington on a state visit. And somehow, as I told you, I have been constantly, so even after NCMRWF was established and I'm we're still trying to get India to be part of the climate program. We want to India to be part of so I wrote to Sikka and Gadgil because I was a member of the Joint Scientific Committee in Geneva so India started Indian climate program. I don't know if you've heard. So in some way, maybe I was making too much noise or whatever. When Prime Minister came, I got an email that that I should meet him. So I had a chance to meet Manmohan Singh for half an hour or so. And this is very important for each one of you also to keep in mind. When you are talking to someone who makes decisions, who has power to do things, you have to speak to the truth. You have to speak to the facts. You don't have to try to try to please the person. You really, the call. You have to speak to the power. And this, so I mean, this has gotten me into trouble many times, but in the end, I think it always helps to. So I told the Prime Minister that we're doing fine, but we can do much better in the whole India's weather and climate enterprise. And one of the big problems is that IMD and NCMRWF, they're part of this a small department called DST, and they are part of that, and they have no independence. They can't do anything. So I cannot take credit that's why Prime Minister did. But 6 months after he came back, he created MOES, Ministry of Earth Sciences, and then very soon we heard, and then you got a lot of independence. So I think that and so I remember all these things when I visited that day and saw that machine. So what do I have to say about the future? And then after that, I'll take questions for you. Okay, it will not be much. Okay. If you go to the European Center lobby, what do you see? You see a curve, or if you see any of their reports, that gives the time series of skill score from the day the European Center was created till today. Why they're showing that? Because they are in a difficult situation. All the other services are doing very well. So how you can justify a European Center unless you are so good or so much better than everybody? So they just put that right there in every report that yes, we are. And you look at any reports, and including your own. Thanks to sending V.S. Prasad sent me the report of 23. You have one curve, I think, figure 2.17 or something, that gives the time series of the RMS or anomaly correlation, but it does give along with the 10 other models and so on. I don't think it is really important for you guys to compare with other models. Yes, I think that you really have to show your own self. Okay, this is what we are. This is how we are doing. So I will suggest that there should be a very rigorous verification of the skill of NCMRWF forecast. And I've talked to many people, and I know there is a verification group and there is a modeling group of MOES and so on. But I haven't seen any product that I can say to people that 1989 NCMRW was created. Today, this is what the skill is. It's just it doesn't take quite a lot of work. It just requires putting together data and so on. And it doesn't have to be done along with 10 other models, because you should be very proud of what you have done. And you should be able to see that. I found one problem in visits to. Oh, so I just said I was in February, and the secretary had asked me to meet with people about the future plans, and I came to the conclusion that although there is a lot of conversation about collaboration and interaction, there is a very little collaboration and interaction. In fact, there is some goes on between IMD and CMRWF and IATM. But my idea is that there should be really active discussion, like a map discussion. Here's the problem. Model did a very bad job here. Let's put our brain together. What could be done? What experiment could be done to be able to test that? That is because of this problem or that problem. Okay, in a way. So I mean, in some way, I know it's a challenging system. You have a operational center in IMD, modeling here, and the model can be run by people, staff. I'm just saying that see if there can be a very rigorous verification, possibly by a third party, if you can engage them, and a very really active discussion among the three groups routinely, I'll say weekly basis, if not maybe monthly to weekly, and engage all the universities, scientists, so that they get an opportunity to use the computer to process the data. And when I went to ITM and I said, this, oh yeah, sir, we have some time allocated for this and so on. They can ask and come. They can ask. They don't know whom to ask. They do. I mean, it's happening. It is happening. I'm just saying is that this is something that, and once you open up, you will be amazed how much it accelerates progress of science. And I'll always use the Indian rainfall data. I mean, I must have annoyed 6 very high government officials. Some of them I knew very well, MGK Menon and, for example, and one of the secretaries, that how come I keep complaining about why Indian rainfall data is not available to Indian scientists? They stated it was not. As soon as that data IMD made available, go and look at the number of papers that have been published in India by Indian scientists, and of course by abroad. It had just revolutionized diagnostic research in India. Likewise, I really think that if these NWP products and the analysis and the gridded information and access to your computer is made to the Indian scientists, you'll really have that thing again. I think that the only one comment is to say I really want to leave a lot of time for a question. I'm assuming, according to my calculation, I have taken like 45 minutes. Is that correct? Yes. Okay, so let me just take a few more minutes and then I really would like to open up for the questions. So I was reading the comments made by different people on your 25th anniversary booklet that you guys made. And I was really amazed by the comment, which I'm sure somebody at NCMRWF probably wrote it for him or somebody in his staff. You know, Jayapal Reddy was the minister at that time when you guys got your 25-year anniversary. And I'll read his comment. Just look. There is need for continued research and development for achieving further reliability and accuracy. I mean, this is the exact word I write at COLA, I write everywhere. It's not just the accuracy, but also reliability. is very important. And yeah, as you all know, and I'm sure those of you who are involved with the verification project, reliability has a very strict scientific definition, and you have so you estimate both the reliability and accuracy separately, because that really helps you give a probabilistic forecast so that the stakeholders can make decisions based on the probabilistic forecast. And his second part of the sentence was, and aim to assume a leadership role in the world. Now, this is an amazing sentence, because let me tell you, this is exactly what my argument was in 1989. Somebody said, why do we need another center? Because we have so many already. Okay. Because we know that it's the initial value problem, right? Initial conditions are very important for short-range forecasting. India should be able to make forecasts over India, which are better than anybody, because you have access to the highest amount of Indian data in real time in this. I mean, whatever other people get on the internet and so on. So I really would like to repeat that statement of the Minister Reddy, that I mean, you all should be congratulated, because you are really part of the first unique institution created in India, dedicated to this new idea that dynamical equations and supercomputers can make prediction. But having said that, please remember there is a huge warning sign. Okay, there's a huge red warning sign on every weather prediction center. Okay, and you should know that. That is AI and machine learning. Now, I want to confess to you that I'm not, being a student of Charney and being interested in the dynamics of system and understanding, I'm not a, I was not a fan of AI. I still am not a fan of AI, but I cannot deny that their forecasts are just as good as European Center. And I don't have to say that. European Center said that their AI-based forecasts are as good as the European Center. And now European Center has adopted AI. And now the European Center forecasts are a mixture of AI hybrid, what is called hybrid AI. So this is one of the main themes in the February meeting I wanted to convey. I really think that you guys have to just be the leaders in AI, because AI is, again, it's based on how you train the data, where the data is. Well, you have the maximum amount of Indian data. So your AI model can be trained in situations which nobody else has. So in principle, while AI is now raising questions about the need for so many supercomputer centers in the world, but we still need very high quality dynamical models, high resolution, because all these AI models are being trained on reanalysis, as you know very well. Although now some of them are now testing, can they train it on direct data and go around the data assimilation system? So this field is in the middle of a revolution, and it is happening so fast that you can't even keep track of it. It's quite dizzying, let me tell you. In July, in Berlin, I attended a summit where the entire summit, there were 150 people, was, let's develop 1 kilometer global models, because we really need that for blah, blah, blah. This last month, I was in another meeting in Geneva where it was all about AI. AI in weather, AI in climate, AI in health, AI in law, AI in business, AI in everything. AI, this was, so it's just hard to keep up with it. But I do think this is a great opportunity for young people to really get involved, learn, so that this is where the field is going. Okay. All right. Thank you all very much, really, for your patience, and I'll be happy to take any questions.
Questions?